Hi everyone, Professor Christina Sover from Cal State Long Beach speaking here, and in this video, we're going to look at materials from Section 4 and Chapter 13, determining whether functions are linear or nonlinear. And as a suggestion, they have that you may want to make an input and output table or draw a graph. I'm going to start with an input and output table. So my input followed by my output. And for whatever reason, mathematicians many decades ago chose that X means input and Y means output in general. So if I put a 0 into this function, I would get 3 times 0 squared plus 5 times 0 minus 1, which is -1. If I input 1 into this function, I get 3 times 1 squared plus 5 times 1 minus 1. Well, that's going to be 3 plus 5 minus 1, which is 7. Now, for this to be a linear function, consistent inputs have consistent output distances. How do I get from -1 to 7? I add 8. So for this to be a linear function, I should get plus 8 or 15 when I go to 2. Well, 3 times 2 squared plus 5 times 2 minus 1. That's going to be 3 times 4, which is 12, plus 5 times 2 is 10, minus 1. Well, that's only 21, which is way bigger than 15, so this is nonlinear. And that's because consistent inputs with the same jump spaces did not have consistent outputs. In fact, here we had plus 14, which is different than plus 8. Moreover, there's a 2 on the exponent of one of the variables, and linear functions don't have exponents of 2. All right, well, let's take a look at the next one. We have x is going to be our input traditionally, and y is going to be our output traditionally. I'll start with 0 again. It's a good number. 0 times 0 plus 5 is just equal to 0 times 5, which is 0. 1. 1 times 1 plus 5. Well, that's equal to 1 times 6, which is equal to 6. Now, 0 to 1 is just plus 1. So I should do plus 6 to the next value. That should work out that way. And I plug in 2. 2 times 2 plus 5. Well, that's equal to 2 times 7, which is 14. And unfortunately, 6 plus 6 is 12, which is not 14. This is actually plus 7. And it's just a coincidence that before there was a 14 and we had a 14 in the second one again. So it's not anything planned here. That's not why it's nonlinear. It's simply nonlinear because consistent inputs do not have consistent output distances. Let me write that down. Linear functions inputs of consistent distances have outputs of consistent, constant, similar distances, same distances. I'm going to put consistent distances. Now, those jumps don't have to be the same both input and output. Notice on my inputs, I'm just going by 1, but my outputs or potential outputs weren't going by 1. Let's interpret C in 2 different ways. P equals 3 to the exponent t will be one way. P equals 3 to an exponent of t versus P equals 3t, because the text is a little bit funky. So we're going to have our input bt and our output bp. I'm going to put 0 for t. 3 to the exponent of 0 is equal to 1. I'll put 1 for t. 3 to the 1 exponent is 3. I'm jumping from 1 to go from 0 to 1, and to get from 1 to 3, I add 2. So I should add 2 when I go from 1 to 2, because that's a consistent jump. I'm adding 1. Well, let's see what happens. 3 to the second power is the same as 3 times 3, which is 9, which is adding 6, not adding 2. So this is nonlinear because right on the side, because the inputs and outputs did not have consistent distances. Let's compare that to P equals 3t. We have t as my input and P is my output. Let's check 0, 1, and 2 again like we have been. I know those are all plus 1. 3 times 0 is equal to 0. 3 times 1 is equal to 3. 3 times 2 is equal to 6. Now I didn't even check the adding part yet. I wanted to get to make sure we had it. I add 1 to go from 0 to 1. I add 1 to go from 1 to 2. To go from 0 to 3, I add 3. To go from 3 to 6, I add 3. So this might be nonlinear. I mean, this might be linear, not nonlinear. And that's because consistent inputs have consistent outputs and their distances. I want to check a negative number though as well to make sure that maintains the same way. Let's check out, I'm going to write really tiny in the top, -1. What's 3 times -1? That's -3. Whew. And how do I get from -1 to 0? I add 1. How do I get from -3 to 0? I add 3. It's going to be linear because inputs of the same distances have outputs of the same distances. I added 1 to each input. I added 3 to get to each output. Cool. Now, this last one here might seem a little tricky. I'm going to rewrite it to make sure we can see it clearly. Y equals -3 absolute value of x. When we are making an input and output table, you're going to think that if you just look at positive numbers, it's going to look like it's linear. I'm going to leave a spot for -1. I didn't before and I should have. Let's just start with 0. By input 0, I get -3 times the absolute value of 0. Absolute value of 0 is just 0. -3 times 0 is 0. -3 times the absolute value of 1 is 1. -3 times 1 is equal to -3. -3 times absolute value of 2 is just equal to -3 times quantity 2, which is -6. Looking at those jumps, I have to add 1 to get to each new input, and I have to subtract 3 to get to each new output. However, if I stop there, I'd say, yeah, it's linear because, all of the jumps have the same distances. Cool. Let's look at -1. -3 times the absolute value of -1 is -3 times +1 is -3. How do I get from -3 to 0? I add 3. Adding 3 is different than subtracting 3. So this is nonlinear because consistent inputs do not have the same consistent distance output. I might suggest going to Desmos to go graph these different functions to see what their graphs look like. I'll give you a very minor sketch. Absolute value graphs look like these. Exponential models look like curves. Linear models are lines. In this case, it's a positive increasing line. And both a and b are quadratic parabola functions. They look somewhat like smiley faces. But I suggest going to Desmos. It's an online graph. I'll leave a link below in the chat or in the description, sorry, so that you can go and practice graphing those different graphs and just using different technology. If you have any questions, comments, or concerns, message me and I'll get back to you as soon as I can. Thanks so much for watching. Talk to you soon. Bye. Stay safe.